All right, so chapter 5, understanding and comparing distributions. So the first thing we have are box plots. Or if you've heard of them before, you've probably heard them called box and whisker plots. And they are a way to visually display quantitative data so before we do this, though, we need to determine if we have outliers. So before we make a box plot, we need to determine if we have outliers. We use the 5-number summary and IQR to do this. So that interquartile range is what's going to help us with that. So to actually determine if something is an outlier, we use 1.5 times the IQR. And then what we're going to do is we're either going to add or subtract that from the Q3 or the Q1. So it would be Q1 minus the 1.5 IQR to find a lower outlier. And then it'll be Q3 plus 1.5 IQR to find an upper outlier. And just as a refresher, IQR is equal to Q3 minus Q1. So I'm going to look at a quick example of this. So I'm going to give you a 5-number summary, and then we're going to find out if there are outliers in this. So the max is 8.67. Q3 is 2.93. Median is 1.90. Q1 is 1.15, and the min is 0.20. So in these problems, they're asking you to check and see if anything are outliers. It could give you the 5-number summary like this. Okay, and so you're not necessarily going to be able to tell them how many outliers you have, but you're going to be able to use the given information to say yes or no, there are outliers or they're not outliers. Because you're going to have your max and your min value, which is either going to be below or above, or it's going to be inside your range, and that's going to be how you determine it. If they give you just a whole list of data, then you're going to use your calculator to find your 5-number summary, and then you'll be able to go from there to actually figure out what your outliers are. And in that case, you'd actually be able to list out the outliers if they give you data. So, should there be any? There's not always. So, my IQR is my Q3 minus Q1. So, that's going to be, in this case, 2.93 minus 1.15, which is what? 1.78. So then to determine the range, okay, this is just kind of a note thing really quick. For reasonable data, we find what we call these up here are fences. Okay, so we want to find the fences for the problem. So we're going to take these formulas and we're going to plug the numbers in to see if we have any outliers. So our Q3 plus 1.5 IQR would be 2.93 plus 1.5 times 1.78. Might be a little bit helpful. I've definitely typed in a whole bunch of numbers before to only realize that my calculator wasn't on. It's like, oh, good. And then to find the lower one, Q1 minus 1.5 IQR. So that's going to be 1.15 minus 1.5 times 1.78. Negative 1.52. So looking at that, does it appear that we have an outlier in our data?
Yes.
Okay. Yes. And we know that at a minimum we have one, and it would be at 8.67. Could be more if we had the list of data. Okay, so we know with certainty we have one, but there could be more in there. Okay, and the same thing, if there had been a lower one, you make the same assumption with this one, or with this type here. So what exactly does this tell us and this allow us to do? These numbers tell us that it would not be unusual to find data values between negative 1.52 and 5.6, but that anything outside of this range, okay, or our fences, can be considered an outlier. Okay, and we already pointed out that we know that our data has at least one outlier because the 8.67 is outside of the max, or outside of the upper fence, but so if it were to ask you to write a conclusion, you'd want to talk about that the bulk of our data should be between the negative 1.52 to 5.6. Anything outside of that we would consider an outlier, and you'd want to list what they are if you were given them. So I'm going to kind of draw a box plot for you to see what it looks like. It does not go with this data that we just had because I want to be able to like make it a little bit bigger and stuff like that. So a box plot is constructed to look like this. So I'm going to just do a number line here from 0 to 500. So if I were to actually draw a box plot or box and whisker plot, it would look something kind of like this. This value here is your Q1, is your median, your Q3, and so then this area in here is your IQR. So the IQR is just what's in the box. These outer lines here are either your min or your max or the closest values to the fences that you have. Okay, so these lines are either the max and min or the closest values inside the fences. And then just note they are not fences. They are just guidelines. Okay, so I'm going to add one other thing to this drawing in a minute. But hypothetically, okay, let's say that, or well, here, let me go ahead and add them in. If you see something like this, sometimes your book will do them as dots, but a lot of times they do them as little, like, the asterisks. But these symbolize outliers. Okay, so before we draw a box and whisker plot, we want to find our 5-number summary if that wasn't given to you. And we want to then use the IQR value, determine if there's any outliers in your data before you start drawing, because your max and your min are not always in the fences. Okay, so you always want to look first and see if all the values are in the fences. If they're not, you're going to list which ones are outliers, and then the next closest data value that's inside the fences is going to become your new max and min on your box and whisker plot. Okay, so let's say that 42 is our fence, and I have the number 45 as one of my data points, and then the number 40. Okay, 45 is an outlier, so even though that's my max, I'm not going to include that on my box and whisker plot. Okay, my fence was at 42, but I don't actually have a point at 42, so I would draw my max line here on the right side at 40 because that was my next highest point that's inside the fences. Does that make sense, kind of? We'll do more, like, we'll actually do examples where you can see it, and then it would work the same way on the other side because, like, you have the outlier down here, so you would pull the next value that's inside the fence. And I mean, it's theoretically possible that your fence could be a data value, but a lot of times they end up being somewhere decimal, so the odds of them actually being a data value are probably relatively slim, but let's see. So kind of a good thing about box plots is that they help you see the middle 50% of your data, and can be especially helpful for comparing multiple distributions you can see the medians, the mins, max, etc., and compare them visually. So if I had, I'm going to scroll back up for just a second. If I had another set of data here, I could do that one like underneath of it. And sometimes you'll see they'll actually be like this as well. They'll give you a box and whisker plot going this direction, like up and down instead. So sometimes you may have another one under it, and then you can see how the min, max, Q1, Q3, median, all that stuff lines up. Comparing your data if that happens. All right, so this next one, not so much that we really do a lot of examples and stuff with it, but it does come up in several of the AP multiple choice questions in the study book, so I feel like it's good to point out, even though our book doesn't do a lot with it, but they are called time plots. So a time plot has time as its x-axis. And so an example of this could be something like temperature and the time of day. So let's do temperature and time of day. So like every hour, what's the temperature doing? And so I'm not going to do any like specific labels on this one. I'm just going to draw what it would kind of look like. But typically as the day goes, it gets a little warmer. And then in the evening, it's going to cool back down and come back down, kind of level out a little bit. Not always true. Obviously things happen, but it would look something kind of like this. So sometimes it's hard to interpret the data as it's given, and so there's a whole chapter on this, but to be honest with you, it's not a big thing of the AP stuff, it's like maybe one question out of the like 50 multiple choice questions about reinterpreting data. So I'm just going to briefly mention it, but we actually usually end up skipping that chapter because it's a whole lot of stuff that we just touch the high points and then we move on. Because it's not that big of a deal. And last time I actually tried to teach it, it took over a week to teach that, like one topic. So I just don't think it's worth spending that much time for it to be like literally one question. But anyways, so you can get a little intro to it. So sometimes we need to use simple math or simple math functions, I guess I should say, to reinterpret data to make it more usable. I definitely just spelled wrong. And so if our data is skewed, okay, that's a lot of times when we need to reinterpret it. And so data that is skewed can be reinterpreted using exponents or logarithms. Which it doesn't really sound that bad to just like hear it, but actually trying to manipulate them tends to be a little bit much. So what we kind of end up doing is looking for tips and tricks for how to figure out what the formula should look like should you need to reinterpret it, and to kind of be able to narrow down a multiple choice question is kind of what I end up doing with it. A lot of teachers comment that they skip that particular chapter. It's like chapter 10 or 11 for that same reason, that it's just not something that's as big of a deal. If you decide to go into the stats field, more power to you. You're welcome to do it, but it's not worth stressing yourself out of in this class over that. So when we talked about histograms initially, we talked about remembering your socks. Okay, so we now have the outliers part of socks. And so the same thing applies here when you compare distributions using histograms, or now box plots. Okay, this is also included now. Be sure to compare your socks. So when you see your box plots laid out, okay, the two whiskers, okay, from, if you want to call it a box and whisker plot, the two whiskers on either end, if one is really long, okay, that's telling you that it's skewed. Okay, it's trying to give you the same information like you would get off of a histogram, just looks a little bit different. And so that's something you'd want to mention. If it's pretty symmetric, you're going to want to mention that. Now, obviously, it's not going to tell you that it's like bimodal or multimodal, but it'll be able to tell you a lot of the other information and stuff like that. So just a quick little example of what this looks like. If you had, and I'm going to try to actually line these up here. All right, and then this one. So if this is my number 2 and this is my number 1, okay, we want to compare these, okay? They're on the same like number line, okay, if we had that like 0 to 500 number line again. Okay, we want to compare these two basically side by side now. So, from looking at this, what is something that you notice about group 1 compared to group 2? That's just by accident.
I was gonna say that, and then I was like, one starts up higher than the
What about and mine's not, again, it's not drawn perfectly, but if we made an assumption that this was straight across right here, let me move my blue line and then make it look a little bit more. Okay, so if we're assuming this is straight across, what does that tell you about the data in group 1 compared to group 2? Okay, so the bulk of our data, okay, in group 1, okay, so like that main middle part of our data, that IQR, is bigger than the median of our group 2. Because this would be my median here. So all of the data in group 1, I should say the data IQR part in group 1 is larger than the median of group 2. What's something else that you notice about it, maybe looking at this part up here?
median is the same as Q.
So the highest 25%, so this is another thing you could say, the highest 25% of group 1. Okay, so that's the Q1 to the median is higher than the max value or the Q1, or I guess technically if it's max, it's probably the Q3, but we'll just say higher than the max of group 2. I guess that's technically not. Trying to think how to word this the best because it's not technically the max. Higher than the Q3, I guess, by how we're describing it. But if it doesn't specify one way or the other, because technically, depending on how it gets flipped, if they start from bottom to top or if they flipped it and it was left to right, so I would have taken either way. Higher than the Q3 of group 2. We would just need to change the wording of this if we were going to call it Q1. All right. Let's see. That's all those notes.